Take a look at the second one. We have this function. We want to find, is it continuous at both of these places? So, well, I'm going to do each one a little bit separate here. First of all, let's take a look at f of, which one's first? F of -3. Let's look at f of -3 first. When we look at f of -3 and we plug that in here, we've got well, we have 0 on the bottom. Notice if we plug in -3 here, we get a 0 on the bottom, which means it is undefined. Right here at -3, this is undefined because we had division by 0. So we know already it's not continuous. It's not going to be a jump discontinuity. So it's either going to be infinite or it's going to be removable. So in order to test this right here, f of -3, let's see, is this infinite or is this removable? Let's look at our table. We want to find the limit as x approaches -3 for f of x. Remember, we're not looking at this one anymore. Don't get caught up by looking at those numbers. We're looking over here at this function. And in order to find what this limit is, we're going to look at a table. It's going to take some writing. It's okay. In order to do this, looking at just under -3, we know that would be like a -3.001, -3.01, -3.1. Just above -3, we have -2.999, -2.99, and -2.9. Well, I'm going to do that trick again. I'm going to type in this function first of all, x plus 3 divided by x squared minus 9. If you want to see how I have that typed in the calculator, there it is. Making sure that the entire numerator is in parentheses, dividing by the entire denominator. I get some value out, but don't worry, we're going to store in different values for x, like a -3.1. Store it for x. Recall that last expression, and we get out different things. So I'm going to fill this in real quick. So notice here, as we plug in this table and we look at where it's going in both directions, it's approaching the same value. Even though f of -3 was undefined, the limit is defined. The limit looks to be a -1.666, or sorry, a -0.1666. So the limit is defined. So the limit is defined here. Because the limit is defined, well, it is a certain type of discontinuity. It's approaching the same value from both sides, but at that point, it's undefined. So we call this a removable discontinuity. And if we look at the graph of it, here's the graph. Yep, look at that value of x, -3. There's nothing crazy going on there. It's kind of hard to see if I box it in there.
Maybe it looks a little bit better.
There's that value of -3 for x, and it's undefined right there at that value, but you can't even see it. It's just a tiny little hole right there. We know it's undefined, but we can't exactly see it. it's removable. If we could just take the fact that it is undefined right there out, we would be fine. So it is removable. Let's look quickly at x equals 3. So first of all, we want to look at, well, what does f of 3 give us? And if we put in a 3, notice once again, 3 squared minus 9 here gives us 0. We would be dividing by a 0 once again. So this, once again, is undefined. Well, what type of discontinuity is it? Well, if we look at the limit, once again, take a look at our table. We put a 3 right here in the middle. Just less than 3 would be a 2.999, 2.99, 2.9. Just above 3 is like a 3.001, 3.01, and 3.1. And we're going to fast forward this, and I'm going to have all the answers. All right, so check this out. As we approach from this direction, our values are getting incredibly smaller. -10, -100, -1000. This is going down. In this direction, so in this direction it was going down. In this direction, as we get closer and closer to 3, these values are going up. And so this is not defined. This does not exist. This limit does not exist here because we're not approaching the same value. And what should make even more sense than before, this is going to be one of the infinite discontinuities. Check out what's actually happening here at the x value of 3. That is an asymptote. As we come from the values less than 3, it's going down. And as we come from the values greater than 3, it's going up to that positive infinity. Here it's going down to negative infinity. So this is not just a jump, but this is an infinite discontinuity here. Good example of that. There we have it.